All right, I want to start with just some plain old memorizing, some stuff that you should be good at by now. And I'd like you to just choral answer, it's called, which basically means you're sort of like a choir and you just say the answer together. And I know some people will be behind to others, and that's okay. Just join in as quick as you realize what the right answer is. This spot is really important. It's what's called what? And don't say 180. Pi, that's correct. This spot is not even halfway there. It's a fourth of the way there. So what's that spot? 1/4 pi, or otherwise known as pi over 4. All right. How about this spot right here? It's purposely not 3/4 pi. There's 30 degrees left. I'll give you that. What spot are we at right there? How about this? How many degrees is this spot right here? Come on now. If this is 30, how much is this? 150. If it's 30, it goes with 150. If I give you degrees, you got to give me degrees back for an answer. All right, I'm going to try that again. Not the same numbers, but let's say I give you this spot right there. What is that in radians? 3 pi. Is it 3 pi over 4 or 3 pi over 2? Those are the two most common answers. 3 pi over 2. You have to have these memorized. This is from the very first or second day, one or the other. You got to know these. All right, next one. These are just some rapid fire ones that you should have memorized. There's pi over 3, there's pi over 6. These are not in order of biggest to smallest. There's pi over 4. There's pi over 2. These are all should be like, I got them quick. And if you don't have them quick, you're behind. You need to start memorizing these because we're going to be getting into problems where if this takes you like a minute to figure out, you're going to take like 10 minutes on every problem because these have to be the easy part, really quick. So what's pi over 3? 60. How about pi over 6? 30. How about pi over 4? 45. And now, I don't know if this will help you or not, but what's pi like? Pi is equal to something. What is it? 180. So do you get how this is really 180 divided by 6, which would be 30? And this is 180 divided by 3, which would be 60? You getting that? Okay, so if that works for you, awesome. Otherwise, if you just plain want to memorize them, that's fine too. How about pi over 2? That should be easy. 90. All right. How about pi? How about 2 pi? And 3 pi over 2? 270. 270, because think about where it is. That's the hardest one that everybody goose ups down here. And that's 90 plus 90 plus another 90, it's 270. Okay? All right. Why do you need to know that? Because on today's assignment, a lot of the questions look like this. What's cosecant of pi over 4? And if you're busy trying to figure out what the heck is pi over 4 again, it's going to really slow you down. Okay, so what is pi over 4 again? 45. All right. And if you know that it's cosecant of 45, at least you know, all right, I know how many degrees we're talking about. And then that'll tell you whether we're in the 30, 60, 90 triangle or the 45, 45, 90 triangle. Do you remember those? Those are really critical old things that you knew in geometry, like the back of your hand. And right now you need to take notes on this because you need to be good at this. 1, 2, square root of 3. Write that one down. Burn it into your brain. You need these ratios. It's going to come up over and over and over. Throughout this whole trig unit, this one and the other triangle that's like it it's just one of the super fundamental things that keeps coming up. The other one is an isosceles triangle. It's got 2 of the sides equals. And yeah, it's the 45, 45, 90. Do you know the ratios on that guy? All right, 1, 1, square root of 2. Now, for some of you that like, yeah, I remember that. Okay, now you have to be able to go further in Precalc. You always have to take whatever you learn, and now you got to go further with it. So do you get that I could multiply this by anything I wanted to, and it's not like all triangles that have sides that are 1 inch, right? Couldn't it be 3 here? And if it's a 3 there, what would it be over here? 3, and then what would it be here? Nope. 3 times the square root of 2. You just times everything by 3. And 3 times the square root of 2 is not the square root of 6. That would be if you had the square root of 3 times the square root of 2. That would be the square root of 6. But do you get how I just multiplied everything by 3? So just because it looks like this on a problem, so what was it again? You got to be able to recognize, oh, wait a minute, those two sides are the same. If those two sides are the same, it's really the 1, 1 square root of 2 triangle, which means it's really 45-degree angles. You get that? All right. How about another option here? Hold on just a sec. What's a really sneaky thing I could multiply that black triangle by that would make something weird happen? Don't say 0, because if I multiply by 0, the sides would be 0, and that's impossible. Yes, sir? Yes, you could have multiply everything by 1/2. 1/2, 1/2, and the root 2 over 2 would be all the sides of it. You thought of something, didn't you? What did you think of? Yes. Root 2 is a really common, sneaky thing to multiply this by, and you're going to have that on your homework for today. Because if you multiply everything by root 2, it looks totally different. This becomes the root 2's over here now. And I'm timesing this by root 2 here. And if I times by root 2 here, it becomes root 2 times root 2, which is root 4, which is equal to 2. So then it's not only the 1, 1 root 2 triangle, it's the root 2, 2 triangle. And that's 45 degrees also. It's the same exact triangle. It's just been multiplied by root 2 everywhere. All right. So let's see if you can use these things now. So if you were taking notes, you know that this 30, 60, 90 is 1, 2, root 3. If you're like me, and it's hard to remember, the shortest side is 1. That's easy. It's whether or not the square root of 3 should go on, which of the sides it should go on. A lot of people get it confused, put it on the hypotenuse. Here's a way to remember it. The biggest side in the triangle is here, and the smallest side of the triangle is here, and they're the ones that have that 2-to-1 ratio. The biggest and the smallest. It's the one that's in the middle that's different, and it's got a different kind of answer, square root of 3. That's just a way to try to help you remember that. Okay, so now that you've got that down, do you get why we can give you a test and ask you to figure out the sine of 60 degrees without a calculator? It seems like sine of 60 is something you'd never be able to figure out in your head, but it's easy if you have this triangle memorized. Because what is the sine of 60? Here's 60. Sine is opposite over hypotenuse, root 3 over 2. You get that? Let's do another one. Instead of, how about sine of 30? Don't say it. Figure it out in your head. Josh, what are you thinking? Good. Same as 1/2, right? Same as 0.5, right? Grab your graphing calculator and type in sine of 30. Verify for yourself that we're not just making stuff up here. It actually works. There's a couple problems at the end of your assignment where you can use a calculator, so. All right. Sine opposite over hypotenuse. Here's the 30. Opposite's 1 over hypotenuse is 2. There we go. It should be 1/2. And is it on the calculator? Okay, good. Let's continue with along these same lines, except starting using the 45, 45, 90 triangle. So if I asked you what's the tangent of 45 degrees, draw the triangle first, no calc, figure out the answer, then verify it with the calc. Once you think, okay, I think it's this, you can find out if you're right or not by just doing the calculator. Got to be able to do what the triangle is. No calcs on the test, so just using the calc as your own little personal checking device to see if you're doing it right. You might ask yourself, well, which of the angles should I be using? And they're the same, so it won't matter. Either way, it's 45 degrees from this angle or 45 degrees from that angle, so that you can do it from either of those two angles and it'll be just fine. All right, I'm not singling out anybody, so I'm going to look at my fish when I say this. Some of you are not actually using your pencil and actually writing these problems out. It's not okay to just sit there. I know even if you think you're just thinking, not good enough. Okay, so I'm talking to my fish, but I'm talking to all of you. So get your, if you haven't already, get these problems started on paper, do them with the calculator to check them. I want you actively engaged here. All right, tangent of 45 tangents, opposite over adjacent, 1 over 1 is 1, and hopefully your calculator verified when you type in tangent of 45, you get 1, right? Okay, good. Then, let's make it just a little harder. What's the sine of pi over 4? Don't say it. Figure out what angle I'm talking about. Then draw the correct triangle that goes with it. Then double check using the calculator to see if you did it right. And it's a fraction, which is a little weird, but you can check it on the calculator and see if it comes out the same decimal. Now, first of all, just to make sure, you don't have to change your calculator in radians mode. I'm saying once you know pi over 4 is what? What is that? 45. So then you can just check it with typing in sine of 45. It's going to be a decimal, and you probably got a fraction answer if you did this right. Just make sure your fraction and the decimal come out the same, and then you'll know if you're doing it right. Okay, so I really asked you sine of 45, and then I really am asking you to take this 45, 45, oh, that's the 30, 60, 90. The 45, 45, and then I'm really asking you to do sine, which is opposite of hypotenuse, 1 over square root of 2. Is what I think the right answer is, and then I type it in the calculator, and it would be some decimal, and then you take 1 divided by square root of 2, and it comes out to the same decimal, I hope. Raise your hand if you got that. Okay, good. I'm going to step it up another notch. What if it's the cosecant of pi over 6? Don't let the cosecant part freak you out. Start by fixing the pi over 6. Figure out which triangle you're in. Once you know which triangle you're in, you don't want it to be that bad. Mr. S, you taking notes? You're working on an old worksheet. Okay. All right, that's fine. That's fine. As long as you're taking notes. Just looked like a worksheet, so I was confused for a second there. Mr. Browsen, walk me through some stuff you know. How can I start this thing? Ooh, there's that way to do it. 180 over pi, and then the pi's cancel, and then it's 180 divided by 6, and so then that's really what? 30. Good. So you figured out that pi over 6 is really 30. So I really am doing cosecant of 30. Tell me what to do now. Know what to do next? Awesome. Triangle done. Now what? Very good. And just to clarify, not really the opposite, but it kind of goes with sine. Okay, they're the flippin' sisters of each other. You're going to do sine of 30, but then that's not the answer, really. You've got to do what to it? flip it. So first I figure out sine of 30, and cosecant is really the flip of this. So I figure out this, and then I flip it. So right away, if I were you, I wouldn't just say that this implies that this is equal to that. So I'm going to put 1 over that. That'll remind me I got to flip it when I'm done. And then sine of 30 I can do in my head. Sine is opposite of hypotenuse. 30, opposite. Yeah, 1 over 2. So, but it's not 1 over 2 then. It's 1 over 1 over 2. So it's what? 2. Raise your hand if you had 2 for your answer. All right, about 3/4 of the class. All right, let's try another one like that. That was a tough one, I know, because we used one of those sister functions. Remember the ones that go together? Let's just make sure you get that. Sine went with cosecant. We just did that. What's the other ones that go together? Tangent goes with cotangent. Yep. And usually in the middle we have cosine and secant. Very good. Okay. So what if I asked you for secant of root 3 over 2? No, wait, I'm wrong. That's not a... No, sorry. We're going to do it to that later. Secant of... we need an angle here that you're used to. Let's just go with pi over 3. Figure out the secant of pi over 3. Start with the pi over 3. Change that to a 30, a 60, or a 45. That's one of those. To figure out what secant goes with. If you want to check if you're doing it right, feel free to use the calculator. But the problem is, you really won't be able to do secant. There's no secant button. But you could do the sister function and then flip it. All right, so secant, my first thought is pi over 3, I hope you knew that one, was 60. And the reason I use that, some people like to just stick with radians the whole time, but the problem is we don't have these triangles memorized with it's the pi over 3. Okay, here's what they would be. This is a 30, 60, 90, right? And we got a 1, 2, and the square root of 3. You think there's anybody out there that memorizes this triangle as the, not the 30, 60, 90 triangle, but the pi over 6, pi over 3, pi over 2 triangle? I'm doubting it. Okay, so personally, I'm going to say, okay, I'm changing that to 60, so I know it's a 30, 60, 90 triangle. Okay, and then once it's 30, 60, 90, and now I'm going to go, okay, I'm not going to do secant. Don't like secant. But I can do the sister one for it, which is cosine. But I got to remember it's not really cosine of 60, it's 1 over that. Then I figure out the cosine of 60. Cosine is adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2, 1 over 2. But this is equal to 1 over 1 over 2. So I got to remember to flip it, and the answer is 2. Raise your hand if you had that one right. Awesome. That's more people than last time. Okay. There's another kind of problem that I want to teach you about, but I'm going to pause for a moment, give your brain a chance to rest from that stuff. And we're going to do a little basics kind of review thing. People at home, you don't have to worry about this. I'm going to pause for a second. I'll come back to teach the last part in a minute. Okay, so we're done with that little basics thing we were going to practice, and now let's do some of these problems backwards. You remember I said that the sine of 30 degrees, and you would be able to make that from the triangle, or just have it memorized. And do you know what this one is? 1/2. If you haven't already memorized it, memorize it. It's going to keep coming up over and over again. It's like the easiest one, and it's just nice to know one. Okay, then, what if I made this the sine of something is 1/2? What's the something got to be? So that's what the questions look like on the other part of the worksheet, is they'll give you the answer as a fraction, and you got to figure out which angle it had to be to make that work. Okay, so I'll give you another one that you wouldn't necessarily know off the top of your head. The cosine of something is 1/2, and it's not 30. Is it 45? Is it 60? It has to be one of those, and don't just guess. What you do is you draw yourself a picture that has a 1 and a 2 in it. Could that be the 1, 1 square root of 2 triangle? Nope. Because the 1, 1 square root of 2 triangle doesn't have a 2 in it. So therefore, it must be the other triangle. Which one is that? The 30, 60, 90. That has a 1 and a 2 in it. So I'm going to draw that. By process of elimination, I know it's got to be the 30, 60, 90 triangle, which is a 1, 2, square root of 3. And then I piece it together and say, what angle was I at if I was going to get an answer of a half? Cosine of what is a half? Was it 60 or 30? Cosine of 60 is a half. And then what you can do is just write the answer like this, and then go back and piece it together and say, okay, does that make sense? Is cosine of 60 equal to a half? Cosine is adjacent over hypotenuse, and yeah, that works. Yay. But you'd still get it marked wrong. You know why? Because they're not going to want degrees. They're going to want radians. So you just have to make one last little conversion and say, okay, 60 degrees is, which one is that again? See how it would be good if you had memorized? 60 degrees is which one? Pi over 3. Very good. So the answer is pi over 3. Now, it will tell you when you want degrees and when you want radians. And sometimes the directions say in degrees and radians. Okay, so it really depends. So always look and see what the directions say. We have to, it's kind of one of those rules as a teacher. If our directions say something, then we have to abide by whatever it says. So we can't say, oh, I meant you should do it in radians, so I'm marking it wrong. If the directions don't say that, you don't have to do that. Okay, so just obey the directions. All right, so let's do another couple of, let's do them off your actual worksheet here. So that'll save you a little bit of time. For today, because I feel like the assignment's just a little long and I'm trying to be realistic, you keep doing your homework. I keep making it realistic size. In this case, I'm Mr. Generous and have you skip all the even primes. Okay, well, what's a prime number, for example? Like 17 and what else? 13, 23. Isn't there one even prime? Yeah, so you can skip. Okay, that'd be kind of cruel. So instead, I'll just have you skip the primes. But that will beg the question, and this is a good ACT little question. Is one prime or not? I bet you we'd have half of you think yes and half of you think no. I'm going to make you go out on a limb and decide if one is a prime or not. And I want you to write on top of your paper either one is prime or one is not prime. In your opinion, what do you think? There is a right answer. So either write one is prime or one is not prime. Give me your gut feeling. Write it down because you have to commit. Because I know a lot of you are going to be like, I'm not sure. One is prime or one is not prime. What do you think? Anybody want to give a strong opinion? See, nobody's gutsy enough to even say. What do you think? You think it's prime. Tell me why you think it's prime. And that's one of the problems is I think that was the definition that you were taught when you were in middle school, that it's only divisible by one end itself. But the technical definition of a prime is that it has to have exactly two factors. So now I ask you, is one prime or not? One is not prime. So bottom line is you can't skip it. So do number one. So let's do number one together. So the first thing I would do on number one is I would do sine of, and I would not do pi over 3. And again, I know some teachers really would rather have you just think in radians, but the problem is we know these triangles as the 30, 60, 90 or the 45, 45, 90. And so that's why I want you to change these to degrees. Pi over 3 is really 60 degrees. So that's the first thing I'd do is change the problem to sine of 60 degrees. And then I would know, oh, that's the 30, 60, 90 one. So then, at the top of your paper, you'll save yourself a lot of time if you draw one really nice 30-60 triangle, 30-60-90 at the top of your paper. You know, because then you can keep referring back to it for all these problems. So here's the 30-60-90. 30, 60, 90, 1, 2, square root of 3. And now I can just look at that triangle and say, what's sine of 60? Sine's opposite over hypotenuse. So from the 60s perspective here, opposite hypotenuse, root 3 over 2. There we go. And since 2 is 2 a prime, Does it have exactly 2 factors? Then 2 is prime, so you can throw it out. So you can cross off 2, you can cross off 3. All right. Let's go to 4. Secant, what is this madness? Secant of pi over 3? Well, pi over 3 I know. What's that? 60. Secant I don't know, but I know its sister. What is its sister? Cosine. You haven't got those memorized? Memorize them. Cosine of 60, but if I just write cosine of 60, I might think that that's actually what I want, and I don't. I want to flip that. So I'm going to put 1 over cosine of 60, and then I'm going to figure out cosine of 60, and then I'm going to flip it. All right, so cosine of 60. I'm going to look at my little triangle again. I got to redraw it, unfortunately. It really doesn't take that long. There we go. And cosine of 60, cosine's adjacent to hypotenuse, is 1 over 2, but then it's 1 over 1 over 2. It'd be really easy to just think, oh, 1 over 2. But you got to flip it, because what we were really figuring out is secant, and that's the flip of cosine. So it's 1 over 1 over 2, and that's, you remember this on the test I just gave you in the basics thing? You got to know how to flip the bottom one and multiply. So you take the bottom one, you flip it over, make it 2 over 1, times it by the top, and then it's just 2. There we go. The answer for that one's 2. All right, let's continue on to the back side. And everybody look at problem number 12. Number 12 says sine of theta equals root 3 over 2. Do you know which triangle you're in? Can you tell by those sides whether it's the 30-60 or the 45-45? 30-60. So it's either 30 or it's 60. And don't just guess. You got to make your little triangle. Okay, if it's sine is opposite over hypotenuse. Which one has an opposite side of 3? It must be the 60. There we go. But look at the directions. Give your answer in both degrees and radians. So 60 is right, but then you're supposed to also give it in radians. So what's 60 the same as? Pi over 3. So there we go. 60 and pi over 3 are your 2 answers that are actually the same. It's like saying 36 inches and 1 yard. They're the same thing, just different units. Okay, let's go to 14 because I think that one's going to freak some people out because they're going to be like, which triangle is that? Root 2 over 2. Do you know one of those triangles that's got a 2 and a root 2 in it? Not the normal ones. But do you remember one of them that could get multiplied up and then it could be like that? I think it's the 45-45. Let me check it for you. So I would write out the 45-45, 1, 1, square root of 2, and then I would go multiply everything by what? Square root of 2. Square root of 2 here, square root of 2 here, and then root 2 here becomes root 4, which is equal to 2. And now that has a 2, and it has a square root of 2 in it, and that one's going to work. So the answer, now on this one, do I even really need to try to figure out which of the angles it is? They're the same. It has to be 45. You don't have to think it through any further. If you know which triangle you're in, it has to be 45. Because there's only one choice. It's not like I can pick this one or that one and they're the same thing. 45 is not the final answer, though, because you have to also say it in radians. Pi over, not 2, pi over 4. All right. Remember, pi is like 180. So you can say to yourself, is it 180 over 4? It is. Okay. And now let's do one like number 19. Number 19, is 19 prime? It is prime. I'll do number 20 for you. Okay, number 20 has alpha is 41. If you look at the triangle that they have, alpha, in case you didn't know this before, that's an alpha and that's a beta. 2 new Greek letters that you're going to be introduced to. We've already been using this one, which is called, you remember? Starts with a T, theta. And we've already been using this one a lot. What's that one? Pi. But there's 2 more Greek letters, alpha and beta. Alpha is also the one that some organization uses as a breast cancer thing, and alpha means a beginning, so it kind of is a nice one for that kind of a thing. It'd be really awful if they used the omega symbol, which is for the end. So anyway, back to alpha. Alpha is that one in the lower right-hand corner, and so it's a 41. And then they said C is 10. That's the hypotenuse is 10. And then it wants you to figure everything else out, which really isn't that bad. This 41 and this 90 tell me what that one is. A good ACT fact to know, add up to 180, right? So you take 180 minus the 90 minus the 41 would be 49. All right, good. And then the other sides, I'm going to have to use trig to do that. And this is where the calculator is going to be necessary, because I said you could use calculators in the very last part. This is that part. Because you are not going to be expected to know how to do sine of 41 in your head. Which ones would you be expected to do? 30, 60, and 45, because we have those triangles memorized. All right, so sine of 41 is going to tell me something. It's going to tell me that and that, so I'll go sine of 41 is equal to x over 10, and then I just solve it using my calculator. I figure this out, some decimal, and I times both sides by 10, and then I'll have it. And then to do the other one, I'll probably use cosine of 41. Cosine's adjacent, and that'd be like y here. Cosine of 41 would be y over 10, and then you go from there. Okay, I think I've given you enough help. I did cut out a lot of problems today, so you have to decide for yourself. If I cut out too many for you, like you really need the extra practice, then you have to be responsible enough to know that, you know what, I better actually do some of the ones I was allowed to skip, but that's up to you. Only if you need that. All right, that's all I have for the video for today.